What we have here is an alternative energy device, and it has a Hemisphere, 2 ground plates, toroid. There's a number of other components inside. Here's the outlet, of course. A number of other components inside of the machine. I'll pick it up and let you look at it. So you can see there's nothing, there's no hidden wires coming to it or anything. There's nothing here, nothing here. It's all right there. And anyway, this basically is a generator, but not a standard generator. Standard generator consumes fuel. This one takes its energy right out of space, or out of air, if you want to say it that way. It's not really out of air, but it's out of space. There's space between air molecules. The way that works is you got positrons and you got electrons. And there's 2 particles. The positron has a positive charge, the electron has a negative charge. They're attracted to each other. And just like if you rub your hair on a balloon, it's attracted to the ceiling. That's because of electrostatic charges. Anyway, these things pair up and they set an orbit up around each other. And from a macroscopic point of view, or our point of view, they appear to be canceled out. But that's by no means the case. They still are there. They're in huge abundance. The quantum physics estimates that every cubic foot of space there's 200 million watts available of power, quite a bit of power. And I believe that's somewhere near correct. So anyway, there's been a number of people that have worked on these machines. As far as I know, they haven't been perfected yet, but they have been to this stage where they are usable. But again, there's more work needs to be done to get them commercially feasible. And here's one model. I think I'd let you look all the way around it. I'll show it to you again. Just so you know, there's no hidden wires or anything like that. Everything's right there. And we're going to plug some things in, test the load. This is a meter, triplet brand. This is set on DC. This is DC that's coming out of here. We'll put this on this wire here. You can read the amps. We load with different loads. Here we have a 110 light bulb. You'll see it lighten up when I plug it in. See it lit up. And we're drawing amperage-wise about 0.39. And it takes a little bit and it'll stabilize between 3.9 and 0.438. It flashed to 3.8 and then it flashed to 3.9 and it flashed to 4. Anyway, it's the stabilization circuit isn't perfect on this thing. But anyway, it's like I say, we still need a little more development on this stuff. But anyway, it gets brighter. That's one interesting thing. It gets brighter than normal, and then it comes back down. Watch it when I plug it in again. See, it gets brighter than normal, and then it comes back down a little. Show you again. That's something that you don't get with batteries, or most generators for that matter. They don't get brighter and then come back down. This is because of the automatic adjustment of the circuit. And actually, if you can watch it in real fast motion, if you watch one frame at a time, you'll see that it goes to half brightness, pauses for just a split second, about a tenth of a second, then goes to above full brightness, and then comes back down. One more time, I'll show you that. And if you want to watch that on your slow motion on your video screen, you can. Anyway, that's runs the light bulb. We can run the other 2 light bulbs with it. We got this one over here. And there we see another light bulb. It's running at 2.0 amps. And it'll adjust down probably in a little bit. 2.1 adjusts up for some reason. Anyway, nice and bright, you can see. It wants to adjust to 2.1. Anyway, that's what that one draws. You can see its useful power. this particular circuit is built pretty durable as far as not heating up. Yeah, actually, if you build these right, you can actually get them to run cold, like air conditioning, that type of thing. Now this little motor, we're going to run it too, and we don't have a plug-in, so we're just going to connect these wires up, in case you're wondering what I'm doing with these wires. Looking at the camera to make sure everything is seeable. Now, hopefully we can do this without causing a short circuit. If I cause a short circuit, there will be a puff of smoke. There you see the motor turning. See the amperage draw went up to 0.2 or 0.1. And it'll go up as I load it, just normally like a motor would. 2.3 amps. Ouch. Take your skin right off. Anyway, it's good power. It's a good little motor we got there too. And basically a little bit about the theory behind it, or a little bit about how things work. I was talking about the positrons and electrons. They are everywhere in abundance. They can be harnessed. They were put together. They can be taken apart. Nature does it all the time. This will run indefinitely. You can see that thing run as long as they want, and you'll see there's no changes. Yeah, and it don't stop or anything else. We'll run it for a while here. If you can see that on the video, it's drawing 0.2 amps. Let me see if I can see it pretty good. I'll zoom in. Anyway, it's between 0.2 and 0.1. Sometimes it flashes to 0.3. Like I say, it's the automatic adjustment mechanism. Yeah. Basically, in order to produce free energy, there's been a number of people work on this. Keeley was one of the early pioneers, John Keeley, and so I'll quote him. He said, you may have to match the harmonic to the inharmonic by thirds. And when you do this, you'll be able to run your appliances without putting in any extra power or fuel. And that's about the case. The hemisphere is one of 4 shapes that produce inharmonic energy. And you do have to produce inharmonic as well as harmonic to produce that, to split these positrons and electrons. And then you have to store them briefly in capacitors or batteries. This circuit just uses capacitors, but it also uses batteries. Not this circuit, but I've used batteries in other circuits. Anyway, you store them after you separate them, and then you can use them for your load. Positrons attract electrons, but if you set up the right vibration, they split and they actually repel for a period of time instead of attract in a brief period of time, like in the microseconds. There's 4 different things that produce inharmonic energy. There's the sphere, the hemisphere, the pyramid, and the cylinder, and you can make wire shapes in all 4 of these. The best, of course, is the sphere.